So this is chapter 7. There are two sections we're going to cover from this chapter: 7.1, estimating a population proportion, and then 7.2, estimating population mean. So what is population proportion estimation? So you would like to find out the population proportion, and for that we use sample proportion. So sample proportion is the best way to estimate population proportion. So that's the first thing we're going to discuss. And based on the given sample proportion, we can find out confidence interval. And to get some level of confidence, we need to choose right size, right sample size. So the sample size, the third one. So sample proportion is the one single value which can be used to estimate the population proportion. And then confidence interval is actually the range of the values used to estimate the true value of the population parameter. I'm going to give you one example. For example, let's say there is a city A, and in this city there are 1 million people, and then we would like to estimate about this population. So we take one sample from here and we find out the proportion from that sample. Let's say a sample of size 100, and from that sample we find the proportion. So for example, for this example, let's assume that we would like to find out of this 1 million people, how many of they do use internet every single day. And for that, to that question, to find the answer for that question, we took a sample of a size 100, and out of 100, 70 of them said they use internet on the regular basis daily. So that means the proportion is 0.7. So now we would like to give some kind of confidence level. For example, I am going to say, hey, I am 95% confidence that based on my sampling process, the population proportion, let's say population proportion is denoted by P, it's in between 65% to 75%. So this decimal form is the percentage, okay? So I'm 95% confidence that the actual proportion from this city lies between 0.65 to 0.75. This interval, I calculate this interval based on this confidence level, and that is called confidence interval. Okay, so normally confidence interval is actually 1 minus alpha, where alpha is called the degree of confidence. Okay, so there is a relation between alpha and confidence level. If alpha is 0.10, which is 10%, then confidence level is 90%. So it's 1 minus alpha. So if confidence level is 95%, then alpha is 0.05, which is actually 5%. Okay. So critical values means it's a G-score which separates the significant values to the right and to the left. So the critical value, for example, let's say this is the critical value, which is the G-score, such that the area to the right side of that G-score under the curve is alpha over 2. How do you find it? By using StatCrunch. We're going to use technology here. So let's look at the relation between the confidence level and the value of alpha. So if you want to find out the confidence level 95%, for example, it could be something else. The value of alpha is 5%, and alpha over 2 is 2.5%, which is 0.025. Then the area under the curve to the right side is 0.025. For this value, we would like to find the G-score. That G-score is critical value. Okay. So these are some standard critical values for a standard confidence level. So if you want a 90% confidence level, then value of alpha is 0.1, which is 10%, and alpha over 2 is 5%. So the G-score for that value is 1.645. And then similarly 95% and 99%. Do not worry about these values. You can calculate this value using the StatCrunch. When we try to find this confidence interval like this, with some level of confidence, sometime we might get error. So we need to calculate what is our margin of error. How do we calculate that? That's called margin of error, and this is the formula for margin of error. The margin of error is, which is denoted by E, is G score for the critical value. This is the critical value times estimated standard deviation. So here P cap is the sample proportion, Q cap is 1 minus P cap, and then N is the sample size. This formula, using this formula, we can calculate a confidence interval. If you subtract, margin of error from this sample proportion, or add margin of error to the sample proportion, you can create an interval from this point to this point. This interval is called Wald confidence interval. So one more time, how do you calculate that? You need to find the margin of error, and then this is your sample proportion. So the actual population proportion can be ranged between this value to this value. That's called Wald confidence interval. Okay, before we do some examples, let's try to correctly understand how to state or interpret confidence level. So for example, let's say this is the confidence interval for any population proportion. The population proportion is between 0.405 to 0.455 with the confidence level 95%. This is just a given confidence level. The meaning of that is we are 95% confident that population proportion has to be in between these two values. Do not, interpret that thing like a chance. That 95% confidence level is not a chance. Do not say that 95% sample proportion will fall between these two. So there are some wrong interpretation as well. Always keep in mind the right interpretation is whenever you have given confidence level with the percentage, we are that much confident that our value for the proportion, the population proportion lie between these two values, in that confidence interval. So one more time, if you repeat and choose many samples, if you go back to the very same example I was talking about, 1 million population, I choose sample 1, and if I keep repeating those samples, sample 1, 2, 3, 4, 5, 6, maybe 100 different samples, 95% of the time, if this is my confidence level, 95% of the time, the confidence interval for those samples will in between these two values. That's the meaning of 95% confidence level. Okay, so before we do the problems, there are some requirements we have to fulfill whenever we try to create the confidence interval for estimating the population proportion. One thing keep in mind, the sample supposed to be simple random sample. Okay, and then the distribution is supposed to be binomial distribution, and these are the conditions for binomial distribution, and at least there are 5 success and at least 5 failures should be there, okay, for that in that sample. So these are the requirement. After that, one more time, this is our confidence interval. And how do you calculate the margin of error? This is the formula for margin of error. And now we are ready to do some examples. Keep in mind, for the round off rule, we always try to use 3-digit population proportion for the population proportion. If you have to round it, then it's supposed to be 3-digit. Okay, so there is one more formula I would like to discuss before we do some problems. Okay, so this is the recap. First of all, before finding the confidence interval, you need to verify that the requirement supposed to be fulfilled. The requirement we discuss here, that's supposed to be fulfilled. And there are different ways to calculate the confidence interval. We are going to use a technology like StatCrunch, and this is the margin of error, and we can calculate the confidence interval by finding these two value. Okay, and then rounding is 3-digit rounding. Whenever we try to use polls, keep in mind, the poll supposed to be simple random, the confidence levels supposed to be provided, sample size supposed to be provided, and then the quality of the poll, except for relatively rare cases, the quality of the poll result depends on sampling method, not the sampling size. You have to keep in mind those things. Okay, so here is the one caution: never think that poll results are unreliable if the sample size is small percentage. And here is the formula for finding sample proportion and then margin of error. If you have given confidence interval, let's say you have confidence interval which is this two value, then let's say instead of giving P cap and E separately, they give you some number for this confidence interval, then you can find sample proportion by adding this two number and then dividing it by 2. And you can find the margin of error by subtracting the lower confidence interval from the upper confidence interval and dividing by 2. So this is very useful relation we can keep for finding the sample proportion and margin of error from the confidence interval. Sometime we need to find out the sample size for certain level of confidence or for finding the confidence interval, and there is a formula for finding sample size. If you have information about the sample proportion, then this is the formula can be used for finding the sample size, for finding the correct sample size to get certain level of confidence. This is the formula we can use. If sample proportion is not given, then this is the formula we can use. Okay, so let's look at some examples from this section. Before that, let's go to let's say some checkup here. Which of the following group has terms that can be used interchangeably with the others? Percentage, probability, and proportion, they are they have the same meaning. A blank is a symbol value. This is the point estimate is a single value. And which of the following is not a requirement for constructing confidence interval? So there are fixed number of trials. This is the requirement. The sample is a simple random sample. This is the requirement. The trial are done without replacement. This is not part of the population part of what is that? Estimating population proportion. And finally, which of the following is not needed to determine the minimum sample size? Standard deviation is not needed. If you look at the formula, the standard deviation is not needed for sample. Where is that? For sample size. Okay, let's look at some examples from here. A magazine provided results from a poll of 2,000 adults who were asked to identify their favorite pie. Among the 2,000 respondents, 11% chose chocolate pie, and then margin of error was given as plus minus 3 percentage points. What values do P cap, Q cap, N, E, and P represents? We need to find their meaning properly. So P cap is a sample proportion. Where is the sample proportion? Sample proportion. Q cap is 1 minus sample proportion. N is the sample size. E is the margin of error. And then P is the population proportion. Let's look at another problem. Where is that? No. What is the alpha? If 99% is confidence level, alpha is 1 minus 99%. So it's a 0.01. It's a 1%, which is in decimal form 0.01. Okay, let's look at, let's do the question number 2. Find the critical value Z alpha over 2 for this confidence level. Keep in mind, you can find this critical value by going here, start crunch. And you can use, remember the critical value is to the right side of this G score. The area is alpha over 2. Remember, alpha is 16%. So alpha over 2 means 8%. You can find the g-score by going stat, calculator, normal calculator. The area to the right side of that g-score is 0.08, which is half of alpha. Then if you compute it, it's going to give you this g-score. That's the critical value they are looking for, 1.41. 1.41. Okay, let's do one example here. Use the sample data and confidence level given below to compute part A through D. So this is the information we have given. Since to find the confidence interval, if you go back to the formula here, you can see confidence interval can be found by finding this margin of error. And for the margin of error, you need to find the critical number. And for the critical number, you have to use the StatCrunch. So in this case, either we use the StatCrunch or we can use the table, but I'm not going to use the table. I'm going to use the StatCrunch. Okay. So this is the information we have given. The sample size is 1036. Sample, success, who said yes is 530. That's a success. Confidence interval is 95%. Answer this question. What is the population proportion? This is very easy problem if you use StatCrunch. So go to the StatCrunch, go to stat, go to proportion stat, use one sample with summary. Okay. And when you click it, the number of observation means that's a sample size, which is 1036. Number of success means how many of them said yes, which is 530. And instead of hypothesis test, which we are going to use later, in future, but in this section, we want to find out the confidence interval with the 95% confidence level, which is already there, standard Wald confidence interval. If you choose this option and hit compute, you will be able to find all the information you are looking for. Keep in mind, the first question is find the population proportion, which is find the best point estimate of the population proportion, which is sample proportion, which is this value. And if you round it to the 3 decimal places, it's a 0.512. 0.512. That's a 3 decimal place. Now, the margin of error can be calculated. This standard error is not margin of error. So don't be confused. It can be calculated by using this relation here. The margin of error is upper confidence interval minus lower confidence interval divided by 2. So in this, here you have given upper confidence interval. Here you have given lower confidence interval. So you subtract lower one from the upper one and divide it by 2. That will give you a margin of error. So it's if I use calculator here, what is that? It's a 0.542 minus 0.481, and then divide that result by 2, that is 0.0305. And if you look at here, they are saying rounded to the 3 decimal place, 0.031. That's a 3 decimal place. Okay, so what is the confidence interval? Confidence interval is already given here. The lower limit is 0.481. 0.481. The upper limit is, go back here, this is the upper limit, is a 0.542. 0.542, and then that's all. So after finding this information, what is the interpretation? The interpretation is there is a 95%, one has a 95% confidence that the interval from lower limit to the upper limit, lower bound to the upper bound, actually does contain the true value of the population proportion. That is the meaning. That's the interpretation. Okay. Let's look at another example. Question number 10. In a science fair project, Emily conducted an experiment in which she tested professional touch therapists to see if they could sense her energy field. She flipped a coin to select either her right hand or her left hand, and then she asked the therapist to identify the selected hand by placing their hand just under Emily's hand without seeing it and without touching it. Among 308 trials, the touch therapists were correct 139 times. Based on this information, answer this question. Given that Emily used a coin toss to select either her right hand or her left hand, what proportion of the correct response would be expected? Since there are two options, so it's a 50-50%, the correct expectation would be 0.5. But what is the right what is the using Emily's sample result? So what is the best point estimate? To answer this question, we can use the start crunch one more time. Here we can go back, choose the calculator, choose proportion, choose one sample, choose with summary, and fill out this information. Based on this information, out of 308 observation, 139 were successful. We would like to find the confidence interval with where is that? It's not given up to now, but what is the success rate? It's a simple one. Even we don't need to find the confidence interval at this point, but later we're going to find it. It's a 139 out of 308. That's a success. So that's 0.451. 0.451. That's the success rate. That's the point sample proportion. And what is the confidence interval? Now we have given confidence level, so we can put that information. That's a 95% confidence interval. Before it was not given, that's why I could not use this calculator. To use this StatCrunch calculator, you need confidence level. So now you can see there is a lower limit which is 0.396 and there is an upper limit which is 0.507. 0.396 and 0.507. One more time, let's check it. 0.396, 0.507. That's the confidence interval. Now, what is the meaning of this? Look at here. The population proportion is in between these two numbers, so it could be less than 0.5. So what do the results suggest about the ability of touch therapist? So look at here, it's not greater than 0.5 entirely. So that means it's supposed to be half and half, but based on this sampling, based on this confidence interval, we can say that that therapist doesn't have that much of correctness. So which one is the right option here? Since the lower confidence limit is below 0.5, there does not appear to be sufficient evidence that touch therapist can select the correct hand by sensing energy felt. Let's go to the second one. Since the confidence interval is not entirely below 0.5, there appears to be evidence that touch therapist can select the no. That's not right. Since the confidence interval is not entirely above 0.5, if confidence interval was entirely above 0.5, then we can say that that therapist had some kind of sense, but it's not entirely above 0.5, so this is the right option. Okay, one more question for finding the sample size. And keep in mind, for finding the sample size, there is a formula. Either you have to use the first one or second one based on either you know the sample proportion or if you don't know the sample proportion. So let's look at this example. Here you are the operation manager for an airline and you are considering a higher fare level for passenger in aisle seats. How many randomly selected air passenger must you survey? Assume that you want to be 90% confident that the sample percentage is within 4.5 percentage points of the true population percentage. So if you go back to this formula, do you have given sample proportion? If not, then go to the second formula. If you have given sample proportion, use the first one. So let's go back to this problem here. Do you have given sample proportion? Assume that you want 90% confidence. That's the level. You have given 4.5 percentage point. That's the margin of error, but you don't have given sample proportion. So you are going to use the second formula. For the second formula, you need to find out the critical value. So what is the critical value here for the 90%? If you go to the StatCrunch one more time, for the 90%, go to the StatCrunch, go to the calculator, go to the normal. Remember, the value of alpha is 10, so alpha over 2 is 5%. So the area under the curve to the right side is 5%, which is 0.05. For this, what is the G-score? G-score is this one, 1.645. 1.644. So that's the G-score, 1.64. And now what's the formula for finding the sample size? G-score is square of that. So I'm going to take the square of this number times 0.25 and then divide this number by the square of margin of error. The margin of error is 4.5 percentage points. So what does that mean? That means the margin of error is 0.045. That's 4.5 percentage point. Square of that number, and hit enter. Whatever number you get, that's your sample size. Always round it to the next whole number. So 332 point something, that means the next whole number is 333. That's the sample size.